So those are considered by the industries these days. So this is the application for the aerospace and automotive industries. And next one. It's a renewable energy application and the biomedical application and sports and leisure applications. So before going into lecture 13, so do you have any question about the lecture 12? Any question or suggestions? No? Actually, each lecture, even part of it, it is sufficient to issue for one semester. So it cannot be go into very detailed manner. So if you give any question, then maybe it will be very good to discuss together. So maybe through email or other method, you may contact me if you have any other questions in other time, right? Okay, let me go into the lecture 13 directly. Right? So this is just the same coverage of we have seen the previous lecture. This is different industry applications. So first, the renewable energy application means wind turbine blades and solar panels are typical ones for composite material application, and the biomedical application, then prosthetics, implants, wearable device is another typical topics. And the sports and the leisure application is a high performance bicycle or tennis rackets and the sports equipment. So where established the business sector through composite materials already. With me, even my case, I'm exercising by a cycle, and my bike is very expensive. I bought because it's a carbon frame, very expensive also. But even the low grade the bicycle these days, they just emphasize this carbon frame, although it has less grade carbon fiber. But that means carbon fiber or other kinds of composite material application for sports goods are very daily life. So you can find everywhere, right? Let's see the renewable energy first. It's harnessing the power of wind. So blade design. Usually that blade is so for the one who doesn't see the interior this wind farm, then they don't understand how large it is. But I believe so many of you have already seen the real the electric power generator. Its height is the tens of I mean it's almost 40 meters, maybe 50 meters. It's very high. And I have experience to engage in the brake system of a blade, the fan blade, this power generator kind of things. That it is very interesting the experience. But this length of blade is about 50 meters, 60 meters, 70 meters. This should be lightweight. because sometimes in accident, this blade can be broken. Then you see that when very fastly rotating case, this tip speed is more than 500 kilometers per hour. That means you can expect how, if it is broken, how far it can be fly. It can fly. How far? And it's very critical to human lives. So anyway, this is needed to be very stiff, but very light. That means everybody can think, okay, composite material is one of candidates, right? So conventionally, the aluminum alloy blade were used, but these days, composite material blades are being applied, right? And one of, I had two PhD dissertation advisors. One of those the composite material specialist, and he engaged to develop the composite material blade. So I heard something about that from him, but anyway, it is not easy because this is very big composite material blade. Its uniformity very important. It's the three. The blade must have very same the uniformity. Otherwise, this will be eccentric the rotating part. So it will make big problem. And blade design is innovative aerodynamic shape and lightweight, high strength material is needed. Okay? This because this can guarantee the turbine blade efficiency, and that can be well satisfied by using composite materials, polymer-based composite. So, and the durability, the cutting-edge composite materials enhance blade resistance to weathering and fatigue, and ensuring long-lasting performance. And the scalability and the development of larger, taller turbine harnesses, stronger, more consistent winds boosting renewable energy. So this is very good application point by using composite materials, and the different kinds of the composite the combination may be able to the design and different manufacturing, because the cost is very high. So cost and the performance should be well combined to develop this kind of blade. And there's a sun energy case. So it's a new solar cell material, and the panel design significantly improved the conversion of sunlight into usable electricity. So for this, it should be the lightweight and the well functionality should be considered, right? So this is backing material, and the cells, some of the cell can be flexible. So it's kind of a composite material basis, and the panel, backing panel also is composite material is used. And this kind of case a little bit smaller scale of automotive or aerospace use, right? But it's coming to the area we are talking today is it's a reinforcement scale is down. And the prosthetic limb and the sensory integration, personalization is a robot arm. Is also one of the main the application of composite materials. and improve the quality of life if possible for medical use by using composite materials. In the case, the differently from the previous large scale of composite material structure, these ones usually nanoscale or microscale reinforcements are considered. So that means rather than continuous fiber, so this is a discontinuous reinforcement or randomly dispersed reinforcement should be considered and others, right? So CNT is carbon nanotube. Those kind of things are frequently used, or some other kinds of chemical or particle can be used. So this is kind of biocompatible ones, biocompatible with this carbon nanotube or the reinforced. Okay? This is a carbon nanotube. So cardiac implant, neutral implant, orthopedic implants, those look like monolithic material based, but to get more the efficient product. So usually composite, nano-composite materials are applied because this should be put into human body. So if you get very heavy, then it is difficult to use, right? So, for example, this kind of the biomedical product. If this is very heavy, although it is well automated and well intelligent, then it cannot be used. For example, at the time of 2007 or 8, on those days, one of university in the United States, they developed the human limbs to compensate loss of arm or loss of leg. At the time, it can be moved. It's reported can move by using the nerve electric signal can be used to move this. So it's very. But at the time, the one arm was 20 kg. So this one is very intelligently controlled by the patient's intention, but that arm is 20 kg. Then how it can be used? So after that, in 5 years or 6 years, they successfully reduced the weight by using a composite material like the lightweight material, and down to 6 kg. So, and I believe it's the more lighter these days. So it's adoptable now. So anyway, weight is very important, and the stiffness, moderate stiffness is important because human when you use any kinds of artificial leg or artificial arm, something like that, it does not support only static load. It should support impact, right? The dynamic load. That means for example, if your weight is the 50 kg, for example, in the case and the impact case, that instant load can be increased up to 7 times. Then be 350 kg in the case. So that structure must absorb those kind of impact in the case. So not just the less grade of stiffness, very high strength is needed. That means lightweight and high strength high stiffness, what is needed? It is composite materials. So in biomedical parts, so different point from others. So in this case, in some interfacing part at least, or implant case, biocompatible is very critical issue. That means medical device, if it is the surgery inside the body or something like that, in that case, the authority approval is mandatory. So it means biocompatible must be satisfied. It's very important issue. So the development, the finish is takes very long time in those cases, and accordingly, the development cost is very high. So it at least 5 or 6, 7 years needed to develop one implant biocompatible device to get approval. Okay. So although it's very attractive area by using the composite materials, but from the personal the background, it is not difficult to be engaged. Most the big the company funded the project only possible for this case. But composite material, especially very advanced, the cost doesn't matter in the case. That doesn't. Okay. So if it is very well functioning, lightweight and biocompatible, something like that, then it will be very good contribution to patients. And this outdoor use for human activity, this is just for health and fitness purpose. In the case we are using many sensor or actuator in this case, but those cases sensors, there are many cases we use composite materials also. And as I said, the sports goods already we can find many the devices that adopt composite materials already, because it's very lightweight enjoyed and good stiffness also can be obtained. And precision and performance in tennis. So lightweight, strength, vibration, dampening, and the spin and the precision, all of kinds of, any kinds of mechanical or the material properties as well as the functionalities can be designed and choose from the composite materials. So composite material, we have already many kinds of, many scale of reinforcement materials, and we have many matrix materials to choose. So there are tremendous many combination the cases based on various reinforcement, various sizes, right? And the matrices. So by those combinations, if you can manufacture or try to make your own prototype, and it can be mass manufactured, in the case there are many chances to get the contribution to various fields. So, and the advanced materials, so this soul material also. It's if you mind on the soul material and the soul design of this shoes for sports purpose, then it has many stories. Although it is very common, but it is not. So because depending on different of exercise, the soul design should be different, and its mechanical property also different, and due to its manufacturing, mass manufacturing technique, the choice of material should be seriously considered. So even for this very conventional shoe, if it is expected to get some advanced function or support to someone to compete, in the case, there are many things to do as a composite material engineer. Okay? And integrated technology pushing limits to the users. So those kind of things are possible to composite materials. So biomedical advancement these days they strongly depend on the composite materials. And biomedical renewable energy, okay, so as a summary, it's a sustainable power source, increased efficiency, and environmental benefits are key points to be considered. And sustainable power source is the solar kinetic body heat to a biomedical device, reduce reliance on traditional battery. And renewable energy provides a continuous reliable source of power, improving performance and lifespan of biomedical technology. Environmental benefit is renewable energy in biomedical application, because in the case the sensor actuation, those kind of need the power source. The power source, so maybe you can use battery inside, but rather than it, if it is self-harvested, it's better. You can use self-harvesting, so that the sensor, it has no battery, but from your body a movement, it can have a mechanical impact, mechanical the behavior all the time during running or doing some activities. Then that kind of action can be source of the energy harvesting. So that sensor can be implemented into that the sensor. Then that sensor looks like permanently operating without any power, but the power is harvested, self-harvested. And the prosthetics is, for example, powering artificial limb. So solar-powered prosthetics, kinetic energy harvesting, and improved function. Those kind of things are issues considered in this application. So voltaic cell is embedded in prosthetic limb, convert sunlight into electricity to power advanced sensors. So you don't need to change by yourself. Right? And the kinetic energy harvesting case, the movement of prosthetic limb can be harnessed to generate electricity. So even in the case, you don't need to replace any battery by yourself. Right? So by using those kinds of the power or supply, you can make many kinds of self-actuating devices, tiny small the bodies. If it is a large one, in the case a larger energy consumption is expected, but in this case very small one, tiny small one, so self-harvested one is sufficient to actuate these ones. So cardiac implant, neural implant, so improved patient outcome can be expected by using this sensor and the small device, the body design by using composite material techniques. It's very important area for application. And the wearable device case also is a renewable energy for health monitoring. So this kind of application, solar powered wearable, body heat generator, and kinetic energy harvesting, improved patient engagement. Those are key issues considered in this application. So it's similar to the biomedical device. These ones also you don't need, many times you don't need to worry about this power. And behind that, there are composite material design and products. And this harnessing kinetic energy, the powering percent is the joint movement miniature generator power. So this kind of very elegant automated artificial leg or arm. So, and as prototype, I forgot the name, startup company in the United States. I forgot, but there is very excellent the product invented there. So I heard he was TD. So TD, in his address presentation, he displayed a very wonderful development. So I was deeply impressed after seeing the TD. But when I got to know the price of it, surprised, because it is not manufactured, mass manufactured. To make that prototype, it is $400,000 US. So who can use that? Who can use that? So seven years ago, about so one of surgeon the approach to me to develop possible development of cheap active artificial leg, so less than 10,000, because he said the motivation to him was he conducted many surgeries to diabetic patients in his clinic. So whenever they amputated their arm or the leg, their disappointment is very deeply sad. By that patient, he is very painful to see. So, but at the time, he said the government supported the artificial leg. It's very like a mannequin leg, something like that. It's no function at all. So it is already about 2,000 US in South Korea. So if any active, he saw the very the advanced artificial leg already. So if that kind of thing is very cheap, then moderately cheap, then it can be the hopeful to amputate the patient, he said. So, so I asked one of my the PhD student. So he's an Indian student. Then now he is working in my institution together, and I asked him to develop one. So the target is the market price is less than 10,000 US. So the running is not possible based on that, but walking is the actively is can support the amputated patient conceptually. His dissertation was like that, and he made some prototype. It's well functioning, I guess, as he graduated finally based on that. But I used very simple to make weight saving. I used carbon composite. It's very light and stiff, And we wanted to memorize the type of working behavior of that patient. So it means if he is, because he has one another leg, so the foot pressure is normal pressure is already gathered. So this artificial leg can get some information by using piezo on the bottom of the foot, artificial foot. So through that we can collect the pressure distribution, and if we want to get some actuation. If he make the falsely the foot bottom is not placed on properly, then it can make automatically the right position. It can, so that she can walk smoothly like this. It's just so a prototype stage is just a few thousand is possible, but not fully automated. But what I thought at that time is, if someone wanted to develop something, as everything is very possible these days, because we did not research any sensor. We did not research any composite materials. For that student case, he just integrate from the existing technology. CFRT already there, and the sensor already there, and to test Arduino already can be obtained. So by himself, he can integrate all of interdisciplinary information, and he can make it work. So it's a very good time to do some development or some contribution to the community, any kind of thing. If you have motivation, then by conducting very basic investigation around you, then you can get to know that sensor is needed, that PCB is needed, that kind of structure needed, and the build is not so difficult. But if you wanted to make it final, the market product, then some money is needed, support is needed. But the basic concept embodiment is not so difficult. So I think most important thing is what are you, or what inspire you. So what is your motivation, and are you willing to conduct any practice by yourself, and you want to finish that purpose by yourself to the finish. So that kind of intention and action can do everything, because you don't need to develop your own sensors, right? There are many pressure sensors, there are many actuators, there are many choices of composite materials. But in the past, it's very difficult, because sensor is a very small number of available, and the size is too big. But these days, MEMS devices, MEMS sensor, they are very cheap, just a few dollars or something like that. So you can make any kind of sensor, and that kind of data can be processed by using the openware found on internet before making it commercialized. So, so composite material is a very contributing technology, I think, because the weight is always a problem. Weight, you know, if you develop something, the final stage difficulty comes from structure, because to make a structure, you cannot use wood for the purpose. If it is not composite materials, maybe the metal should be machined. But to machine that metal into final shape, it requires cost. But composite materials, the pre-preg can be available. And that can be processed by yourself without big trouble. So by using the stacking the tape as you wish, you can make anything around a PVC pipe. We use the PVC pipe around it. Pre-preg can be taping, and it can be heat treated at a relatively low temperature. Right? It is sufficient to see your own the design. Of course, the commercialized product are a little bit different story after that, but the composite material is very useful material to be applied even by yourself, because it is not need the machining like metal. And so capturing body states, this is another the energy the obtaining technique. So this can be used together with the composite material or structure. Okay. And the solar powered wearables, and this advanced, the advancing remote healthcare is also possible. And challenge and consideration in biomedical renewables, and so power efficiency, miniaturization, safety, and biocompatibility, and the future material in renewable energy biomedical application. So also you can check after this slide. It's just a summary about what I said so far. The performance bicycle carbon fiber frame is very common these days, and rechargeable electric motor also. I have some the study about electric motor too. So I have experience to develop the power pack and the battery the pack, and the electronic brake. The three different modules can make any kinds of mobility. Right? So what I think is so if we can make a very light motorcycle, in that case it is very usable or contributable to motor riders, because if it's a full-scale motor rider, not a scooter, in that case that body weight, total weight is heavier than 200 kg for the Harley Davidson full scale motorcycles, over 200 kg. But the mania on motorcycle for those kind of full size one, so they cannot enjoy that kind of motorcycle as they get older, because it is too heavy. So they cannot manage it. They cannot manage that weight. So after 50 years old or 60 years old, they just give up that full scale. They just going down to scooter, something like that. But I think if we use composite material structure, in that case, I simply calculate then possibly the whole overall weight of a full size performing motorcycle, the electronic motorcycle is about 100 kilogram kg. It's possible in the case equivalent to scooter weight. So someday I wanted to build those kind of ones. So I developed power pack and battery management system, and the wireless electronic, and I got so part of it, American USA patent. So I wanted to build those kind based on the composite materials someday. So what I wanted to say is, so if you have some interest in the composite materials, because it can give you the much weight saving and high performing mechanical properties and the mechanical characteristics. So there are many things you can do. So this kind of series lectures, it's not good to address about detailed technique for calculation or design issues, something like that. This is just for introducing what kind of issues are handled in this community. So that's this series lectures purpose. But if you have a strong interest toward something, then please consider about the use of any kinds of composite materials. Then you can maybe find something someday. So this kind of renewable energy source, solar-powered charging station, we can find these days in many places, but still there are many things to be solved still. So next, in the next lecture, we will think together about recycling. But the advantage of using composite materials and the possibility of existing the manufacturing technologies is already the size of useful to be adopted already. I think. So the day by day, the new reinforcement material is being introduced into the market. So graphene, carbon fiber, or any other kind of natural fiber or natural reinforcement form can be found around. So far, I think we have all over understanding why composite material is seriously considered for the industries and any kinds of basic materials, but we don't know the details yet, because we are just having the conceptual ones only. But the most happiest one is that all of these well-prepared resources are waiting for us, because all of application stage is just the beginning stage. It's not so well saturated yet. So any kinds of idea based on the composite material structure is highly recommended to you. And the next lecture, we will close this lecture by addressing the recycle technique, something like that. Okay. So I'll see you tomorrow at the last lecture. Do you have any questions about this? Do you have? Yes?
What kind of practice we can follow to identify the application in real life? If we can see the slide, we can see the illustration, and we can detect the real life world, like I am moving through on the road, and we are seeing that one vehicle is broken down. So how can I identify that this part can be replaced with the composite material so that it will serve the purpose? So how can we decide this?
So you have already understood three strong points by using composite material, right? Weight saving and intentionally anisotropic stiffening, right? And the next one is how it can be manufactured. Right? So you know three of those. Right? So that means I want to get more like one. Okay. Among part you are using these things. In that case, it's a weight saving product. It can give you much more benefit. Then you can think, okay, this part can be replaced by composite material part. Then what kind of a composite system is appropriate to that? Then you can start to choose. There are many choices. Okay. So the weight saving is among part you are using, or I need more strong one. This part, this direction is very, the more strength is needed. Okay? But the other direction doesn't need it. But if you are using very strong, the alloy for the part, in that case, all the direction has the same strength. That means usually is supported this direction, only except this one. Then you can seriously think, okay, if I replace this part as the high performing composite material, then it will be enhanced. You can think like that. So weight and strength, directional strength is a good point you can think replace it by composite material. It can be replaced, right? Right? Yeah.
So what are the important steps to take whether this material is sustainable or not for particular system? So what are the steps and how we can approach to get the sustainability of that particular material?
The sustainability means durability. Durability. It's the overlap concept, I think. So sustainability means we want to satisfy that product for a long time without degrading the function, something like that. Right? Yeah, performance. So sustainability. Sustaining environment. For environment, so composite materials. So already, if you adopt composite materials rather than other conventional ones, you are already doing so at least 1 point. Because in manufacturing process, as you saw, the composite material has no waste. So there's no extra the waste of material. But if you use the metal or other things, you need to get machining or there are many waste already. So that means using composite materials rather than others is contributing to environmental sustainability already. So next lecture, you will think full lifetime the cycle of the composite material is that to eventually contribute to environmental sustainability. Okay. You will talk now. Okay. Yeah.
One more question. Please give me some idea about the photocurable elastomer resins, which can be 3D printable, biocompatible, right?
Biocompatible. Next time you asked the silicon, right? So, what kind of the part can be of the goods by using the silicon-based one? 3D printed one.
Yes, sir, silicon based.
So actually, after your question, I have not seriously think about it. I promise I will give my the response tomorrow.
Okay.
Okay? It's kind of homework to me, right? I'll give you service tomorrow, right? Thank you very much. Today is Sunday, so tomorrow is Monday. So after the morning lecture tomorrow, in the afternoon, soon after that, I will leave for Korea, and I was very happy to together with you through this kind of introductory lecture series, and so whenever I give you the addressing, I think this is to a vastly wide range of lecture, because I just barely know the very simple part of it, because I'm computational guy. Computation, mechanical side, not material engineering or the aerospace engineering. I'm good at the mechanics of composite materials. So maybe I made some mistakes to share my information together with you. But whenever you have some question, even after watching the videos later, then feel free to send the email to me. Then I will study together with you to give you a good answer after that. Right? Thank you very much. Let's see you tomorrow.